Okay, question one. We've got investigation insulating three materials. Here is a graph representing the cooling curve for each material. So start off around about 80 degrees, and we can see that the temperature decreases to around about 50, 50, just over 50. Here we have the temperature drop above just below 40, and here we have the temperature drop all the way to 20 degrees. So material C, we can clearly see, has dropped the most amount. Now, if we now look at the first part of the question, it says what was the temperature of the room when the student carried out the investigation? So if you have material A and B, which are covering this beaker, show that the temperature is dropping, but the temperature hasn't completely dropped. So it will carry on going after time. Okay. Now C has shown that the temperature is leveled off. So the temperature of a room normally is around about 20 degrees, 23, 22 degrees. So we can see that here the temperature is leveled off, and the water has cooled down to the temperature of the room, which we expect to happen over the long run anyway. And here that is 20 degrees. So that's the answer to part A. Material C has the highest thermal conductivity. What does that mean? Highest thermal conductivity means that it conducts the most amount of heat. It lets through the most amount of heat um, through the actual insulation. So how does the graph in figure 2 show this? How do we see that material C lets the most amount of heat in? Because we see that the temperature has changed from 80 degrees to 20 degrees. That is the biggest temperature drop out of all three materials. So you will say they got the largest temperature decrease. Part C shows that the beaker of water is now insulated with thicker insulation. So suggest how using the equipment in figure 3 will have affected the student's results. So we've gone from thin insulation to thick insulation, and that's what you will mention to begin with. The thicker the insulation, what we're expecting is less heat to escape. So the temperature is going to remain relatively high compared to if we had thin insulation. So not a lot of heat is going to be lost, but heat will be lost. So the thicker the insulation, the lower the rate of heat loss. So what we're expecting is the temperature decrease will be lower for thicker insulation for the same given time. One mark for saying it's thicker insulation, saying what we see, and second mark explaining what we will most likely expect. So we're expecting the temperature decrease to be lower for the thicker insulation for the second mark. Okay, so now we've got a data logger that is measuring the temperature, and we compare that to if we were to have a normal thermometer measuring the temperature. Now, we can clearly see that the data logger is measuring to one decimal place, but we have to judge by our eyes what the actual in between temperature is. Quite difficult when it's a very small area. So it's either 39 or 38. Can't really tell what exactly it is in between. So compared to the thermometer, the data logger will have a higher resolution. Higher resolution means we can measure to a greater precision, more decimal places. Compared to a thermometer, the chance of misreading the data logger is lower. Now, when we're looking at a scale like this, when we are looking at a very tiny area on the thermometer, we can easily misread, whereas that is very difficult to misread. Um, it is a digital display, so there's a lower chance of misreading. So, as we said earlier, thermal conductivity means how quickly heat is lost. So, felt wood loses more heat for every meter. Um, Mineral wool will lose less heat, and then out of all of them, polyurethane foam loses the least amount of heat per meter per degree. Now, which type of insulation is most effective at reducing the rate of cooling? So what we are doing is we're trying to keep the heat in and reduce the rate of heat loss. So as a result, we need to look for something that will let less heat through, so lower thermal conductivity, and polyurethane foam has the lowest thermal conductivity, and that's your reason. Give your reason, less amount of heat loss, um, because if you look at that, that value is the lowest thermal conductivity. Now, if we chose felt wood, that would mean that more heat is lost per meter per degree, which means it's the direct opposite of what we're trying to look for.